Hi children, in the last class we started the second part of this chapter, force and pressure. That is, the second part of this chapter is pressure. Then what is pressure? Do you understand? What is pressure? The force acting on a unit area of a surface is called pressure. What is the equation for pressure? Pressure is equal to force by area. Pressure P is equal to force by area. So, what is the unit of pressure? That is, force is Newton and the unit of area is meter square. So, the unit of pressure is Newton per meter square. Hope you understand that. Then, what will happen to the pressure when the area increases? We have studied it in the last class. That is, as the area increases, the pressure decreases. And as the area decreases, the pressure increases. We discussed many daily life examples related to pressure. That is, hammering a nail, cutting vegetables using knife, drilling machine, etc. Then we move on to the next topic. What is the next topic? That is pressure exerted by liquids and gases. First, we are going to discuss about pressure exerted by liquids. What is pressure exerted by liquids? I hope you studied about the three forms of substance, that is solids, liquids and gases. Do you remember? In the previous classes you have studied solids, liquids and gases. Here in the solids, when we place, here it is a table, here it is a table and I place a wooden block in this table and I push this wooden block. I am going to push this wooden block. The wooden block will move. That is when pressure exerted on the solids. Now we are discussing about pressure exerted by liquids. My question is, are liquids exert force like solids? Here we said that the solids exerts force. Then are liquids exerts force? Okay, we can find it. We know that liquids are always kept in containers. We take a bottle. Here is a bottle and this bottle contains water. That is, this water occupies in this container. Do liquids exert pressure? Yes, they do. That is, this here it is the water. This water exerts pressure on the walls of this container. That is, yes, the liquids exerts pressure in downward direction and sidewise direction. That is, the liquids always exerts pressure on the walls of the container. Here the water exerts pressure on the side wall and the downward part of this bottle. So, we can say that the liquids exerts pressure on the walls of the container sidewise and downward. Okay. Liquids, the first point is liquids exerts pressure on the walls of the container in sidewise and in downward direction. Okay, where will the pressure is more? I already told you that the pressure is exerted in the sidewise and in the downward direction. Where will be the pressure is more? Here there is variation in pressure. Where will be the pressure is more? Let's look at it. That is, the pressure has a variation when the depth of the bottle increases. Suppose this is a bottle. Here is a bottle filled with water. Here is a bottle filled with water. Then suppose first I am going to make some holes in the walls of this bottle. First I am going to make a hole at the top of the bottle. Here I am making a hole. Then what will happen? The water will fall through this hole. Suppose this is like this. That is, here the water will fall downwards through this hole. Then I am going to make a hole that is at some depth. I am making another hole and the water will flow through this hole. That is like this. Okay, the water will flow through this hole like this. Then I am going to make the next hole at the bottom of the two holes, that is here. When I make a hole in this, here the water will fall like this. You can do this experiment by taking a bottle filled with water and making 3 holes like this at different heights. Okay, then the water will flow like this. What do you understand from this? This hole be A and this hole be B and this hole be C. Then from these 3 holes A, B, C, we can assume that here at the hole A, the water flows slow compared to B and C, slowly. Then at B, the water flowing some more fast than A. Here the water flowing some more fastly than A. Fastly than A and slowly than C. Okay, at the hole C, the very fast the water is flowing at the hole C. Okay, very fastly, very fast. Okay, at hole A the water flows slow. Here B the water flows fast, and here in the C the water flows very fast. What can we understand from these 3? That is, the water is flowing through this hole and the pushing of water, that is, the force applied by the water is more in the hole C as compared with A and B. C exerts more pressure because the water exerts more pressure at C because the water flows very fast at C. Okay, so as the depth increases, here more depth is for C. So we can understand that at hole A, the water moves slowly and the depth of A is very low. Here it is very low depth. Very low depth. Here the pressure exerted by the water is very less. Pressure exerted by the water is very less. So the water moves slow. Then B, at B it moves fastly than A. Fast than A. That is, here it is in low depth, and here the pressure exerted is less than that of C. Here the pressure exerted is less than that of C. Less than C. Then at C, here the water moves very fast. That is, the pressure exerted by the water is very high. That is, pressure exerted by the water is very high, and it exists at a high depth. Okay, high depth. At A, the depth is very low, so the pressure is very less. At C, the depth is very high. Here the hole exists at high depth, more depth. That is, the pressure exerted by the liquid is more here, that is high. Then what can we understand from these three? That is, as the depth increases, as the depth of hole increases, as the depth increases, the pressure exerted by the water also increases. When I make a hole here, the pressure exerted by the water is more here than that of this. Then here the water moves very fast. Okay, the water will move very fast. So here I am giving you the relation between the depth and pressure. The depth and pressure. That is, what is the relation between depth and pressure? As the depth increases, the pressure also increases. As the depth decreases, the pressure exerted by the water or liquids decreases. Okay, as the depth increases, here see the point, the hole C exists at more depth, and it has more depth and it has more pressure. Here the hole A at the topmost of this bottle, that means here the depth is very less, so the pressure exerted by the water is very less. That is, as depth increases, the pressure increases, and as depth decreases, the pressure decreases. Hope you understand that. This is the second point. That is, as the depth increases, pressure increases. As the depth decreases, the pressure decreases. Here at A, the pressure is very low because the depth is less. Here at C, the pressure exerted by this water is very high because here the depth is very high. Okay, what will happen when I make 2 and 3 holes at the same depth? Here at the same depth there are 3 holes. We can say it as E, F, G. Here this water exerts equal pressure. Okay, here the water exerts equal pressure. That is, here at the same depth the water exerts same pressure. These 3 holes are existing at the same height or the same depth, so the water will flow with the same speed. Okay, then the pressure exerted by the water is same here. So there is the third point, that is, liquid exerts equal pressure at the same depth. The liquid exerts equal pressure at the same depth. That means the water will flow at the same speed here. Okay, liquid exerts equal pressure at the same depth. In your textbook, you can see the figure. In this figure, the height of the water is here, and in the second one, the height of the water is here. That means which rubber balloon bulge more here? Bulging of water balloon is more here because the water is more here. Here there is less water. Here more water exerts pressure. That means here the bulging of this balloon is very more. Here the bulging of balloon is very less because there is only less water here. Okay. that or otherwise we can say that the height of the water in the pipe is less here. So the bulging of the balloon is less because the pressure exerted by the water is very less. Okay, hope you understand that these two figures, that means we can conclude that as the height increases, the pressure increases. As the height of the liquid increases, the pressure increases. That means liquid exerts more pressure at more height. And there is also another activity, it is given in your textbook, that is here a balloon is fitted in the side of the bottle. When the water is poured, the balloon will bulge. When more water is poured into the bottle, the balloon will bulge more and more. That means the liquid, this water exerts pressure on the walls of this container. I already told you the liquids always exerts pressure on the downward direction and in the sidewise direction, that is on the walls of this container. That means because of this the balloon here bulges. Already discussed that liquids exerts equal pressure at the same depth. When I make 3 holes at the same depth, the water will flow at the same speed. So we can understand that it will exert same pressure when we that is liquid exerts equal pressure at the same depth. When we make hole at different height or different depth, as the depth increases, the pressure increases. As the depth of liquid decreases, the pressure decreases. Hope you understand the 4 important points, that is liquid exerts pressure on the walls of their container, pressure exerted by water at the bottle of the container depends on the height of its container. And next point is, as the depth of the container, as the depth of the water increases, the pressure increases, and as the depth of the water decreases, the pressure decreases. And there is another point, that is at the same depth the liquid exerts equal pressure. Okay, then we move on to the next topic, that is pressure exerted by gases. What is the pressure exerted by gases? Then we are moving to the next topic, that is pressure exerted by gases. That is, we already talked about pressure exerted by solids, pressure exerted by liquids, and now we are going to pressure exerted by gases. Here we all know the balloon. Here I am taking a balloon, then I am blowing through this balloon. When I blow through this balloon, the balloon will bulge. That means when I blow through this balloon, the air will move into this balloon and this air exerts pressure on the walls of this balloon. Okay, isn't it? The air exerts, that means the gas exerts pressure on the walls of this balloon. So we can understand that there is only one point you have to study, that is gases exerts pressure on the walls of this container, on the walls of the container. Here the container is balloon. Okay, here the container is balloon. Here the gas exerts pressure on the walls of the container. Hope you understand that. Then today we are discussed about pressure exerted by liquids and pressure exerted by gases. Hope you understand all these things. In the next class we will discuss about atmospheric pressure. Okay, we will continue in the next class. Thank you.